Good morning, everybody. So this is my second class about this digital image processing. Yesterday we have discussed the introductory part of digital image processing and the course outcomes also we have discussed. Srikant, please mute yourself. Okay, right. So digital image is a very interesting field, but requires certain fundamentals of the signal processing, and we require the knowledge of filtering design and all these mathematical vectors, mathematics, and etc. Fundamental prerequisites are there, but still, without the prerequisites, also we can explain the digital image processing subject. So, but if the mathematics is in your hand, you can freely design your computer program with more efficiency. So that is what we are working. And but don't be so much panic about the mathematics of this digital image processing part, as we are moving towards the digital era. So that means the program is of our main concept rather than the mathematics part of that. So many routines are available and libraries are available. Nobody is not they are not going to write a program for uh, neural networks or computer vision. Those libraries are readily available. We must know what to use and why to use and when to use. So that means a little introductory of image processing is enough to design your projects. So that's why the trend has been changed from mathematics to programming now. So mathematics is required, but in this introductory course, we are not going to focus much priority is not there for our mathematics. So let us concentrate more on programming and understanding the fundamentals. So keeping in that mind, we are designing our course, and you also focus on the same thing, as local other textbooks are not available for this digital image processing, and maybe if available also they have copied from only the Gunjala's textbook. So now I will show you the textbook, and I will give you the soft copy also. And uh, throughout our discussion we are focusing on only one textbook, and the textbook also provides you so many materials, ppts, and projects, etc. Right. So now let me open my OneNotes, and right. So I'm sharing my screen. Yes, yes, Lily Joy, F2. You have any questions? Right. Satyanarayana. Right. Anyway, recorded portion also I will give you. Don't worry. So I'm sharing my screen. Please bear with me. Right. Now, see, this is a digital image textbook. Digital image processing textbook, 4th edition. So this is Rafael C. Gonzalez and Research E. Woods. The 4th edition only you have to follow, because the 4th edition consists of so many advanced MATLAB codes are available, and clear description is given. So let us have this textbook 4th edition. You take from library, and or otherwise the PPT slides are available. So Lily Jai, you can unmute yourself and ask me question. Right. Right. So all of you keep this textbook in your hand so that easily you can understand my concepts. And the very important part of this is you have to learn this with this Octave software. Already yesterday I explained. Still one more time, it is better to explain to you. The Octave is similar to MATLAB, and most of our even Python commands also is similar. So that means if you learn the Octave or MATLAB or Python, almost they are similar. So don't think that Python is different and Octave is different and MATLAB is different. Almost all are compatible with small little changes. So if you learn one software perfectly, the others also you can learn very easily. So that is the requirement of this day. So we are focusing on the programming part. Already I explained you. So the first step is, this is the command window. So first you need to read the image. So for reading image, first you need to select the path of this image. So C user searches this new folder. Are you able to see this one? Or otherwise I will share mine. Or otherwise I can zoom it also, no problem. Now this image teja.jpg is there present in the C folder, new folder too. So that I would like to read. So for that, what is required is I require to use a command called imread. The same imread can be, for example, in Python, we use CV2. Open CV is required, and CV2.imread. That is only the difference, right? Teja dot. So you must use the laptops for understanding this, or otherwise phones also you can zoom it yourself. So once the image is read, then what you need to see, for example, I would like to see what is present in first pixel. So the image is like this. For example, let me explain with one note. So for example, if you have an image like this is my image. Like this, some image is there, for suppose this is my image. Now what I have to do is I have to divide this entire image portion into small pixel areas. That means the number of rows like this. Parallelly you can note down, I think so. All of you keep your notes ready. Like this, you divide this into rows and columns, and this particular one is one area. Whatever may be the intensity present in this one, this is x-axis, or suppose this is my x-axis, this is my y-axis. Let us suppose this is my y-axis, and this particular intensity value present at this particular point is known as f of xy. Note down f of xy. So in signals, only f of x is there. It is only function of x, but it is two-dimensional, so it consists of f of xy. X-axis is there, rows are there, columns are there. For example, this is my 0 pixel, 0 row, 1, 0 column, 2, 3, 4, and like this here also 0, 1, 2, 3, etc. So now what is this pixel value I have means at this point, what is my rows and columns value is 0, 1. So this is 0, 1. And what is the intensity present at that particular point is the average of the intensities present in this point. So that means 0, 1. There may be value ranging from 0 to 255. Already I explained this. 0 to 255. Why 255? What is the reason why 255 means? We have, for example, 8 bits to represent this 8-bit ADC. The one we are using is 8-bit ADC. So 8-bit ADC means 2 power 8. So 2 power 8. 2 power 8 means how many values will be there? 256. So whatever may be the values present at this particular point, it may be some 9, it may be some 10, or it may be some 200, like this. So that means it is only a just number matrix. So you can represent entire image as a matrix format like this. That may be some 1, 2, 3, 1, 2, 3, 4, 5, and 6, like this. So that means so what is the image processing is just dealing with the matrices. So that means you must know how to deal with matrix and matrix operations and all those things. If you know clearly well, then you no need to worry about the image acquisition part for processing. So let us also see after reading this image, I have three images present in this. Already explained yesterday, but now one more time I am explaining you. So see, the size of this one is 193 rows and 261 columns. And but what is this 3? 3 is nothing but it consists of 3 parts. Actually, image consists of 3 parts. One is the red part, and second one is G part, and third one is B part as a color image. So color image consists of 3 integrants is required. Red, how much red I want to add, how much green I have to add, and how much blue intensity of this blue if we add, that particular color comes. That is our RGB picture. So that values I have displayed in this one. Let us go this way. So what is my I of I1, IR, for example, red. What is my red intensity if I want to know? Then I of colon comma 1. You see, I am show I R. So it displays only the gray color image, not RGB image. Just wait for 1 minute. Now see, it displays only the not color image, only intensity values will be present. And now I would like to know what is my data present in IR. So if you press IR, you must know what are the intensity values present in this IR. So you see, these are my intensity values, rows and columns will be there. And so see here, it may be 158, 165, and something is 3, and something is 4, something is 0 to 255. It ranges from 0 to 255. For example, 0 means it is almost like black color. 255 means 0 means almost is a black color, and 255 is almost a white color, almost white. So that you have to keep it in mind. And for example, I want to have only the IR of only one value I would like to have. What is present in, for example, 20th row and 20th column. Let us see what is that value, 180. So that means like this, IR of, I want to know only one value of some 28 comma some 250 for suppose. What is that value? So undefined line, that means it is exceeding limit. How to know what is the limits? IR. So you require the laptop to understand this. 193 and 261. IR consists of size of this one is 193 rows and 261 columns. So maximum is 261. That you have to understand. So it cannot. So 193 rows and 261 columns, and it belongs to unsigned integer values. But how computer transmit these values? For example, 160, some 20 is there. So how to represent 20? 20 with so equivalent digital values like this 11100 like this. So 8 values should be there. Okay. Next. For example, my image is I am show I. My image is this one. For example, I would like to convert that to RGB image. How to do this? RGB to gray color. Sorry, RGB to gray. I3 for suppose. So I am sure. So these comments are similar to your MATLAB comments only. Same comments I am typing actually. So see the picture. So it is the gray color image. So that means you can equivalently convert the color image as a gray color image and you can perform certain tasks. So like this, you can convert it to black and white, and sometimes you can have some threshold algorithms. All these things we will discuss in course, main course with our programming. So let us start our class with this introduction. So all these PPTs I have obtained from the textbook PPTs only. So it is not under plagiarism, right? So already yesterday I explained you about the course outcomes and the textbook also. So digital image is a one-dimensional, two-dimensional function which has x and y coordinates. Already I explained you. So, and it has f is an intensity value. We call that as amplitude as intensity value. For example, 255, 261, those values are intensity values are gray level. The same thing can be, we can name that as a gray level values also at that point. So digital image processing, it is not restricted to only converting one type of image to another type of image, and there is no certain boundaries for this. Somebody may put that there are certain boundaries, but exactly as per the textbook is concerned, there are no certain boundaries. Like it can be used for computer vision, it can be used for artificial intelligence, it can be used for human eye emulation, and so many applications, machine learning applications, and computer vision applications, and security applications, X-rays and gamma rays, and medical applications, and biotechnology applications, and farming applications, industrial applications. There are so innumerable applications for the digital image processing, and the nowadays it is gaining more popularity because of the artificial intelligence. So right, so almost we can build robots only if the digital image processing is advanced. So this is the first picture of digital picture produced in 1921 from the coded tape by telegraph printer method. Actually, we cannot call this as a digital image, first digital image, because computers were not used at that point, even not invented, and they have just transmitted certain codes through telegraph, and they could reduce the time by this is for newspaper industry. Uh, for example, New York to some other state, And actually the distance for transmitting that by manual method is almost 1 week, so they could reduce time from 1 week to 3 hours. So nowadays you can imagine at that time reducing from 1 week to 3 hours is a big achievement. Nowadays even 1 second, or it's not even we are transmitting now my digital PPT here, you are able to listen and you are able to understand also. So imagine how much development has been developed by our electronic engineers. So you must be proud of our electronics. So much advancement is there in electronics field. And don't think that computer field is different and electronics field is different. Both are same. The computer is nothing but an electronics device. So don't separate the computer engineer and electronic engineer. Both are similar. There is no difference. So they have reduced the time from 6 days to 3 hours, but still, so this is sent by submarine cable from London to New York. Here they have mentioned clearly reduced time to less than 3 hours from more than a week. So that is the big achievement at that time. And the picture of the US spacecraft Ranger 7 took this image on 1964. At time also they have mentioned, you see, 17 minutes before impacting. Okay. So that is courtesy of NASA. So you may, for example, whatever the images we are seeing nowadays, it may not be restricted to only visual spectrum, and they are ranging from the gamma rays to radio waves. So that you have to see. So it may be ultrasonic wave, it is scanning electron microscope, and so many others are also there. So visual spectrum is a very, very less spectrum that we are using. So see here, it is only the visual spectrum is ranging from 400 to 700 nanometers wavelength. But we are using the entire spectrum from the gamma rays, that is from 10 power minus 12 to FM radios, and 10 power 4 microwaves we are using, IR we are using, X-rays we are using. So, but human eye can visualize only the ranging from this 400 to 700. But image processing, we are with our camera, we can extract only this portion. But we are using different cameras for gamma rays, X-rays, UV, microwaves. All are very, very useful. So almost all the spectrums they are using for different applications. We will see what are their applications, and that means the image processing means don't restrict to our cameras, means mobile cameras and webcam cameras, and all these cameras are only a just small part of image processing. But the entire the electromagnetic spectrum can be used for the processing applications. So the X-rays is very, very important application. You can understand the bones present in your like for example hands or arms, for example like legs. For example, if any break is there in your leg, then immediately they will take the X-ray and they can understand. But what is the use of image processing there also, we must understand. Nowadays they're almost emulating the human vision, means exactly at what particular exactly at what particular location the damage has been occurred, and how, what is the amount of the damage, and what is the perimeter of the damage, etc. Everything is calculated by can be calculated by our image processing algorithms. That means even the crack size and what is the type of medicine, or what is the methodology adapted for this type of cracks, and everything can be emulated, and that can be given to doctor. So that helps, image processing helps a lot to the doctors. That is there. Next, infrared radiation. So IR images, infrared images we can, what is the use of infrared images means, for example, uh, somebody, they do the most of the crimes that occurs in dark places only. So for example, in dark places, if light is not there, we cannot take the images with our normal cameras. Then what we have to use is, we have to use a specialized cameras with IR radiation, so that can capture even the objects present in the darkness also. So that means you can do certain projects with infrared cameras, where you can put your cameras in dark place, and alarm can be means alarm, even for example ATMs, first what they will do is, in ATM also it is required. For example, the criminals, what they do is, they switch off everything, and they may can go inside and crack the ATM machine, and they can take the money out. So that can be avoided by this infrared cameras. So you can do certain projects with IR cameras, that will be added more value rather than a normal camera. So that means the data acquisition part is not restricted only to the visual spectrum, and certain projects you can do with other areas also. So only five minutes time is left for us. Now the floor is open for any discussion, and tomorrow also we will continue, and so many other projects also we can do. And don't restrict that this 40 minutes time is only we will teach. It's not that. You can share your views in separate forum. So we'll create a forum for your doubts, and we can discuss throughout the day. So don't worry. So this is only a presentation for our recording purpose, and you can ask doubts. Now I'm stop sharing, and the floor is now open for doubts. One by one, you can ask.